Alright, hello everyone, this is Giles Male from Full Stack Modeler, and I am going to be walking through a really nice MECC case called Meal Plans. This was a case designed by Peter Schall. Awesome case, and I love it for a number of reasons. I think it allows us to showcase the power of a few things really nicely, not least the use of Excel tables, which adds a huge amount of value in here. So I'm going to walk through all of the bonus questions, all of the 7 levels you can see here, and I will talk through a few things. I'm going to obviously try and go through what I think my kind of natural solution would be. I'm going to try and make the point as I go through a few times that there are multiple ways of solving anything in Excel, really. So I'll just leave some things for you to take away and perhaps research further if you're interested in. It's a really nice case in part because I think there's not too much complexity to get your head around. So this is a case about meal plans. And if we look at the detail here, we have some food prices for 50 food items here. We have prices that vary across these 4 districts. And then we have essentially like a set of transaction data almost, which is order numbers from 1 to 1,000. There we go. And we've got some information about the student. So the student name, what was the food that they ordered, what was the district that they are in, and what was the quantity of that food ordered. So 2 really nice and actually very well structured tables of data here that we're going to lean on to answer lots of the questions. I'll just read it really quickly, the instructions in full. I assume if you're looking at this, you probably would have done the same. So you were searching through the University of Arizona's archives and stumbled across meal plan information for some of the university's most famous alumni. Instead of selling this information to the tabloids, you decided to sort, review, and analyze what you found. Good choice. The information you found has been summarized onto 2 tabs, food prices and food data. Those are the 2 tabs I just showed you. The food prices tab contains the cost for 50 food items for each of the university's 4 districts: Historic, Global, Highland, and North. And the food data tab contains 1,000 food orders. Each order contains the student who ordered, the food they ordered, the district where the order occurred, and the quantity they ordered. Get to work on your analysis, and hopefully you don't regret your choice not to sell this information to the tabloids. All right, there we go. So not too much to read. Nice and simple. We're going to start with bonus questions 1 to 4, and you actually get a nice sort of guide here saying, does this relate to any particular level, or can you answer it straight away? So the first 4 levels we can answer straight away, and then bonus 5 naturally links to what we're going to do in level 7, which is by far the sort of most complex in this workbook. All right, let's go through. So bonus question 1, which food has the highest straight average cost for one quantity of the food across all 4 districts? All right, so naturally, I'm going to want to go into my data and I'm going to want to start using it. What I would probably do in battle conditions is I would just start by actually copying the 2 sets of data just so that I've got these sort of raw backups before I do anything. So the first thing that I'm going to want to do is convert my 2 tables into Excel tables. Now, when I do this, I'm going to hit Control T, and I get a slightly different dialog box than you will see because I've got an add-in called Monkey Tools, which just in part allows me to add the name of my table straight away. So if this wasn't battle conditions, if I was in the real world doing a model, I might go to the length of having a prefix, TBL, and putting a full name for my table in, like food prices, something like that. Because we're thinking of battle conditions, I'm going to make this easier for me to call up. So I'm going to call this FP underscore. Now I want to be a little bit careful here because I've got this row at the top, food cost by district, that I don't want to be in my table, and it's picking up that row at the moment. So make sure it starts from row 2, and my data has headers, that's fine. Hit OK, and we now have our first table. I will do the second one as well. So if I go to my second raw data source, this is food data, so I will call this FD underscore. hit OK. And now I have my 2 data sets set up as Excel tables, which is definitely what I want. So let's go back to the question. Which food has the highest straight average cost for one quantity of the food across all 4 districts? Straight away, we're going to get into a decision point here about how we want to do this. Do you build something explicitly as a new field of data in your table, or do you try and wrap it all up into what I now call the sort of array dimension? Do you try and do all the logic in the logic of the single cell here? My natural default still, where possible, is to kind of explicitly add the data, especially if I think I might need to use that at some point later on. So it wouldn't be a surprise to me if something like an average cost could be useful later on. I'm going to go into the data set that I've got here. This is the table with the cost by region. I need an average for each food type across those regions. And I'm literally going to start typing in average, and that's going to extend the table and allow me now to type in a really simple formula, which is the average of those 4 district prices to the left. You can see a lot of benefits straight away with Excel tables. I'll assume you've got some knowledge of them, but with Excel tables, as you can see, if you type in some formula logic in the first row or anywhere else really in a field, in a column, it's going to copy that logic across the row, so you get that kind of standard calculation logic. If data was to extend, then the table would extend as well, which is very useful, albeit not necessarily in this battle case. But I think one of the most useful things is you can start to call up the table field names very quickly. So if I start typing in FP underscore, I can get my tab key on the go, left square bracket. And if you look at that formula bar, I can start to pick fields or other sorts of items from that table of data. So my one bit of advice to you straight away is, if you're not familiar with Excel tables and structured referencing, is get really comfortable with them, because you can do so much with them when you're trying to work at speed. Then from here, what are we trying to do? Well, we're trying to find the highest average here. Now, you could do this in many, many ways. I wouldn't be surprised if some people kind of went to the extent of doing a rank here. You've got formulas like rank EQ, where you could say, let's look at the whole field and look at the kind of row we're on. And that didn't work. Let's try that again. That's because I've probably put them the wrong way around. Let's look at the number we're looking at in our specific row and rank it in order across that entire field of data. Let's get rid of those decimal places. You could do something like this, and you could search for the 1. You could index off the 1. But I think that's really unnecessary in this case. If we get rid of that, we can use a really nice trick that you'll see some of the kind of very experienced players use with things like XLOOKUP. So if you think of something like an XLOOKUP here, we can search for a value and then we can specify a match mode. Now, all of those averages, those prices are pretty low numbers. So I'm looking for the largest number in that average field. If I put a really large number in here, something like 100,000, or I think that's 1 million, that's much higher than any single number is going to be in my average field. And then I can look up that number in the average field, and I can return the name of the food. And then I want to go to match mode. And this is the important part, because I don't have to just default to an exact match. If I look at one of those options there, -1 is going to do an exact match or the next smallest. Put in -1, close the brackets, hit enter, and it gives me the answer. So we've picked a number that's far higher than anything in our list. Then we've said you're going to search for that number or find the next smallest number and return the food that is aligned to whatever row that's in. And that's always going to give us the highest number. So the answer is yogurt. I'm not going to worry too much about where the formulas go in here. Yogurt is the first answer. We can just check that if we want. There we go. So what else could we do? All right, there's a few other things you could do. That's me being relatively explicit to get to an answer here. Imagine if you wanted to do this all in a single cell. You could use something like by row. Okay, so by row is going to apply some sort of logic on an array by row. So if I went in here, and I'm not going to use this average field at all, I'm going to highlight that block of prices across the 4 districts. And the second part of the by row function, by row syntax is the function. And here I'm going to choose the average. So it's going to look at that array, which has 4 columns and multiple rows, and it's going to apply this calculation logic by row. If I just hit enter there, I'm going to get a spill. So it's trying to give me the average across all of those rows for every row in this table. But think of what I could do from here now. So I could actually kind of use the same logic that I was leaning on there. That's going to give me the average by row. And now what I could say is X lookup. I'm going to use that really large number again. Let's go with, I can't tell if that's 1,000,000 or 100,000. We'll put another 0 on. What's the lookup array? Well, it's that list, that spilt array of averages that I've just calculated with by row. And what's the return array? It's the food. So I can call up my table. I want to find the food field. And then I just need to go to that match mode again, -1, close the brackets, and there's the answer. So there is a way that you can lean on what I now call the kind of dynamic array or the array dimension. You can do all the logic in one cell. I'm not going to do this for every question because we'll be here for about 5 hours. Okay, moving on. Which food has the most quantity ordered across all 1,000 orders? So again, if we go over to the second table, we've got the foods and we've got the orders. And again, there are lots of ways you will see people approaching this. I really like the unique function. So if we went to unique and we just got ourselves a list, a unique list of all of the food items, we could also then use a SUMIFS to calculate all of the quantities for all of those food items alongside that list. It's a dynamic array. So if I just reference the first item in that unique list and then hit hash, close the brackets, that's going to give me the sum of the quantities by food type. Now from there, what could you do? Well, you could sort it. So I could highlight my array of 2 fields there. This is not a great way to do it, the way I've done just with the sort of traditional grid referencing. I'll show you what I would tweak in a minute. The sort index in a sort function is basically choosing which of the fields you want to do the sort by. We want to sort by the numbers, which is the second field. And then the sort order will be descending. We want the largest number first. That's going to give me the answer here, ramen noodles. Fantastic. If we wanted to actually just leave ourselves with the answer as a single cell, you can turn to something like index. You could use take and drop and other things, but index 1, 1 will leave you with just the first row and the first column's answer. Okay, I mentioned that this wasn't a great way to do this because I've actually not kind of kept that dynamic array logic and functionality going. So what you can do here is something like this. You could do within that array, you could just highlight H3, which is the start of the array, hash, colon, and then highlight the first cell of the second field in your 2 column array. Hit enter. It will still work, but now if for some reason we had a new product, if we hit enter, you can see that that dynamic list is extended, and the list here will have extended with it as well. I will just reverse that before it mucks everything else up. All right, so our answer there is ramen noodles. Bonus question 3. What is the overall average cost per order? So again, I think you get to a point here where you have a decision to make. Do you try and do this in the array dimension, or do you just explicitly add some data? And for me, I would just be explicitly adding data. I'm going to just shift this over. Let's have a think of what we want to do. If we want to get to the overall cost per order to then create an average, we're going to have to get the overall cost of each order first. So I think for the first time, we're going to have to do a kind of link between our two tables of data. So let's call this food cost. Hit enter. Because I've set this up as an Excel table, the moment I start adding text to the field to the right or underneath the table is going to expand. So food cost, and then we'll put total order cost. So the food cost, what do I want to do? I want to bring through the relevant cost of the food for the district from my other table. So to do that, I'm going to use XLOOKUP. What do I want to do? I want to basically do like a two-way lookup. So we're going to look for the food, popcorn, in the food prices table here. And then when you kind of do a two-way lookup, you actually nest an XLOOKUP within an XLOOKUP. I'll show you how you do this with an index and match as well. When you get to the first return array for an XLOOKUP, this is where you do the nesting. So we're going to do another XLOOKUP. This time, we're going to look for the district in this list of districts here. Don't be confused by the way that the text looks in the formula. This is all structured referencing, so it will look very different to normal cell referencing. And it's at this point where you then add the return array, which is that kind of two-dimensional table of data, the prices for the food items across those four regions. Close that off, and that gives us the food cost for each of the food items by region. Now, if you don't know XLOOKUP, this is one of those cases where you'll see people doing it other ways. You will see lots of index match people. So what do we do with index match? Kind of the reverse in terms of the kind of setup structure. We want to index this two-dimensional grid of prices across the regions and the food types. And then we have two matches. So the first thing we're going to match is the food in the row to the list of food here. And then there is another match type element we've got to put in. So I will put in 0 exact match, comma, and then we use the second match, which is for the district against our header of districts here. And it's another exact match, 2 brackets to close it off, and you get the same answer. I'm going to go back to my XLOOKUP just because that's kind of what I'm used to now. All right, and then the total order quantity is really easy. It's the quantity times the food cost. From there, what can we do? Well, let's go back. So what is the overall average cost per order? This now should be a really easy formula because we can just take the average of our total order field that we've created. $90.47. Let's just check the answer. Yes, we're all good. Okay, bonus question 4. Which student spent the most in the Highland District? All right, we'll try and do this a different route just to show you a few other options. In fact, I'll show you a couple of ways. So which student spent the most in the Highland District? Again, I think we're going to be using this food data table here, and I think this total order field that we created is going to be really useful. So you could do a few things. You could lean on something like a filter, and you could say, all right, let's filter, apart from, we don't really need the order number, let's filter the whole table of data and only include items where the district equals Highland. You don't need a double brackets at the end, so get rid of that. And what that gives us is a filtered list. So from here, we could do a lot of work to kind of work. What was the question? I've forgotten the question. Which student spent the most? We could do some work to sort this in order, find the person with the most spend. But I think you could probably shortcut this another way. So you could do a sum ifs. If we do a unique here, unique on the student. Let's just get that list of students. And then we can just use sum ifs with, I'll show you. So sum ifs. What do we want to sum? We want to sum the total order cost. And we're going to want two criteria, basically. So the first criteria will be that the student here matches the name of the student in our unique list. And this is where sum ifs can be really powerful. We'll add another criteria. And in this instance, the criteria is that the district equals Highland. And we've basically got the same problem that we had before. So we could sort this if we wanted to, or we could do another round of our X lookup where we look for a massive number and we look for it here. And we return the name of the person that is the closest match. Remember, we've got to put the match mode on, -1, search for the exact match, or next largest number is not what we want. Next smallest. Let's try that again. And the answer is Amy Davidson. So we'll put Amy in. And we're doing pretty well. All right, so bonus question 5 we're going to leave. Let's get on to the main levels then. So I think we're going to be using a lot of lookups here. If we just read through each of the 7 levels. So number 1, given a food, what is the cost of one quantity of the food in the historic district? That feels like a simple lookup. Level 2, given a food in a district, what is the cost of one quantity of that food? So it's almost the same question, but we've got 2 criteria to deal with this time. We've kind of been looking at the solution for that already in some of the work we did for the bonus questions. Level 3, given a food, how much of it was ordered across all 1,000 orders? I think that's going to be some sort of a sum ifs. Level 4, given an order number, what was the cost for that order? And again, I think that is a lookup, and we may even be able to take an even shorter shortcut because we have this order number, which I will come back to. Level 5, given a food, what is the total cost that was ordered across all 1,000 orders? Again, that feels like a nice lookup. Level 6, probably a sum ifs, but essentially you are doing a lookup and summing it. Level 6, given a student and a district, what was the total cost of all of the orders in that district? Again, I think we can probably lean on sum ifs. And then level 7 was the trickiest one. Given a student and a district, what would the total cost of all their orders have been if they all occurred in the given district? So we're going to have to do some tweaking to the data for the first time here. The reason why I just stopped and read through all of those levels was I wanted to just get a sense, before I dived into level 1 and started building, was there anything in here that made me think that there was a really strong link between any of these levels? Is there a point that I think I'm going to have to turn to building a reasonably complex model of sorts on a separate tab, and perhaps then start to kind of build model logic that answers multiple levels at once? I think the answer to that is no, and that means we can just go through this level by level quite nicely. So, level 1, given a food, what is the cost of one quantity of the food in the historic district? Again, I think we can lean on something like X lookup or your lookup function of choice. We're looking up the product on the right here. We're looking that up in our food field in our food prices table, and it's just for the historic district. So we can just reference the historic district, hit enter, And there we go. Now, one thing you will notice people that are very experienced in these competitions do is rather than reference one cell here and then copy and paste down, they'll just reference the whole array. And for something like a kind of one-dimensional lookup like that, you will then get an array output that gives you all the answers at once. I showed you the index match option. I just want to show you something else as well. And again, this is something that I'm training myself up to use more and more. The modern array engine of Excel is so powerful in so many ways. So how could we have done this without actually leaning on any sort of lookup function at all? Well, you could have just said, we want to kind of filter this table of data, the food table here, just by the rows where the food is equal to the food item on the right. And we're going to multiply that out by the historic price field. Okay, we'll put brackets around this. Now, if I try and do that, it's going to give me a huge spill array. But if I take this over to the side, I want to show you what this is doing. Let's put it all the way over here. It's giving me a list now of either zeros or the price where the food in that row matches whatever we've got here. So it's essentially a whole bunch of zeros apart from the one row where we have the price where the food matches the item here. So what could we do? Well, we could just put a sum around that. And that's going to give us the right answer. So we haven't used anything other than a sum, but the modern kind of array engine with Excel allows us to do that. I'll leave you to explore that further if you want to. Let's get rid of that. All right, so I've just deleted the answer though, so let's put that back in. Is that saved? No. All right, you're going to have to watch me do it again. So XLOOKUP cheese in the food and return the historic price. Okay, level 1 done. Level 2, given a food in a district, what is the cost of one quantity of that food? We're doing exactly the same thing, and actually, as you saw me do in one of the bonus questions, I'm going to use essentially a two-dimensional XLOOKUP, an XLOOKUP nested within an XLOOKUP. And the way you do that is you pick the lookup value of the first part of the logic that you want to look up, which is the food. So we'll look for cereal in the food field. That didn't work. Let me try that again. So we are going to look up the food here in the food field. And then we're going to nest. So XLOOKUP again. What's the second thing we're looking up? We're looking up the district in the list of districts. That is just pulling through the headers from the table. That's why it looks different in the formula. And once we've got those two lookup kind of references made, the final thing we do in the second return array is we reference that two-dimensional block of prices for the foods. Close that off, and that will give us the answer. Should probably check it. Let's just have a quick look, make sure I'm not doing anything wrong. Good, all good so far. Level 3. Given a food, how much of it was ordered across all 1,000 orders? So let's have a look at what we've got. We have our foods, we have our quantities. Everything we need is laid out there perfectly for us. You've just got to get comfortable with these core functions like SUMIFs, XLOOKUP, and things like that. So what are we going to be doing? We're going to be looking and summing up the quantities across all of the orders based on the rows where the food matches the food listed in the row to the right. Okay, close that off. And that is our answer. Let's just carry on this good practice of making sure we've actually got the right answer. That looks good. All right, so nice use of SUMIFs, Nice use of structured referencing. It's nice and simple. I keep kind of turning, I'll show you this again, but I keep turning when I do a sum ifs like this. I'm going over to the actual table itself. I'm using some keyboard shortcuts all the time. Control, page up and page down to navigate between the worksheets. And I use Control and the arrow keys a lot to then navigate quickly within. If you have Control Shift held, and you start at the top of a field and you press the down arrow, that's going to act like a sticky key and it'll highlight the whole field for you, which is the point where you see the formula switching to the name of the field. How else could I do that? Well, as I said earlier, you could do something like this. You could actually get into your sum ifs function and you can start typing out the name of your table. So that would be something like FP if I wanted the prices table, or FD, I think it was. The tab key finishes the name of the table for you. Left square brackets to start looking for a particular field within your table, and I could pick whatever I want and use the tab key from there. Okay, so we've answered level 3. Level 4. Given an order number, what was the cost for that order? So again, if we just look at the data we've got order number references here from 1 through to 1,000, and it's asking for the total cost of the order. So you might default to doing what we've done a number of times already, okay? You could do an X lookup, you could look up the value of the order, and you could look that up against the order number field, returning the total order cost, and this will give you the right answer. Let's just double check that. Yeah, I was just overriding the example to see if it matched. So you can do that, that's fine, but don't forget the power of something like the index function on its own. Index, ignoring the match, is going to return the position of the number that you choose. So for example, we have our table of data here, very nicely ordered from row 1 through to row 1,000 with the order numbers from 1 to 1,000. So we don't even need the X lookup. I could literally just go index. What do I want to index? I want to index the total order cost for the food, and the row number that I want from that field array is the order number. Okay, and that is going to give me the right answer as well. Just double check that. There we go, overwriting the example just to check it matches. Level 4 done, just with an index function. Level 5, given a food, what is the total cost that was ordered across all 1,000 orders? So again, this feels like a really nice sum ifs. So given a food, what is the total cost that was ordered across all 1,000 orders? Equals sum ifs. We want the total cost where the food matches the food that we have here. Copy that down. Just check that against the example answer. Perfect. Level 5 done. Level 6, getting into harder territory. So given a student and a district, what was the total cost of all their orders in that district? I don't think this is that much harder. So if you're comfortable with the idea that with the sum ifs, you have the ability to use multiple criteria, one after the other, it's pretty much the same as level 5 with one more set of criteria. So the sum range, again, is going to be the total order cost. And this time we've got 2 criteria. Let's go back. What are we looking at? The student and the district. So the first filter, or the first criteria, will be the student, listed here. The second criteria will be the district, listed here on the right. Okay, and that gives us our answer. Check it against the example. Oh, let's undo whatever I just did there. Let's check it against the example. Lovely, that matches. Okay, so level 7. Level 7 is a fair bit harder. So what have we got? Given a student in a district, what would the total cost of all of their orders have been if they all occurred in the given district? So we have the name of our student and we've got the district. Now, if you were to look at any one of these people, like Richard, for example, so let's actually do that. Let's have a look at Richard in our data, just because he was the name I picked. You can see Richard has orders across multiple districts, and that will be the same for everybody, basically. So we've got to tweak the data. We've got to figure out how many orders Richard or whoever it is has. And we've got to adjust the pricing so that the price of the food is always whatever is listed here. We are going to run into some real frustrations with the way Excel tables work here. I think it's kind of unavoidable. But let me show you what I would do. So I would, again, naturally lean on adding some explicit data to my food data table here. So I think I'm going to have 4 new fields: Historic, Global, Highland, and North. And I'm going to want to calculate essentially a version of the total order, but just with the pricing for the order for each of these districts. What do I mean by that? Okay, well, let's just do it. So I'm going to do an XLOOKUP. And I want to bring through the price for the food type for this district first. So I'm going to say XLOOKUP, the food, in our table of food, and we're going to return the price from the historic field here. Now, if I do that, what's it going to do? It's going to give me this one list of prices. If I copy this across, you'll see that the reference always stays here with the historic field. So there are other ways you could do this, but I'm going to manually update that. However, I'm going to just add to this formula first. So this gives us the price. I'm going to do the price times the quantity, and that's going to get us to the total price for this order as if it was in the historic district. So copy that over, and I just need to make one little tweak here, which is for each of these references, I'm going to change this to the global field. Here it's still referencing historic, so I'm going to change that to Highland. And for North, change the lookup field from our other table to North. And a nice sense check here would be the global district should match. So we've got the global district order price cost here, 53.85. And global here matches. Okay, what have I got? I've got the total order cost for each of these orders as if they were ordered in any one of the 4 districts. So now that we have those extra fields of data set up, what I would have turned to a few years ago would have been a sum product. So sum product would have been a way that we get the sort of array functionality working really nicely when you have 2 dimensions. And we could have done something like this. We say, look, we want to just sum the products where our student equals the student name that we have here, and where the district matches. So we've got our 4 districts listed at the top here, equals the district listed on this row, and multiply that out by whatever the total costs across those 4 fields are. And that would have got us to the answer. If I just copy over the example answer, 3238, copy it over 3238, okay? So sum product was always my sort of go-to function when I was dealing with array calculations that had more than just like the one field to look at, where you could use something like a SUMIFS. The really nice thing about the modern Excel engine is you don't even need the sum product anymore. So you can literally just use sum, and it will do exactly the same thing. So if I take out the sum, just to show you what that's doing in a bit more detail, let's just copy that formula over to the side here, but I'm not going to sum. We get into this sort of binary logic thinking where it's going to only return values where all of the criteria are met. So the row will only return numbers where the student name matches the name we've got listed. And then in terms of the columns, it's only going to return numbers instead of zeros where the district matches whatever we've got here, which, I just pulled this from this formula here. So it's only going to give numbers in that final column because that is where the north costs are. So I think that's a really nice thing to master, leaning on the modern Excel array engine. And from here, we should be able to answer bonus question 5. So which student spent the most if all orders were in the historic district? Let's do it two ways. Let's do it the way that I've been showing you so far. We'll just explicitly lay this all out. So we want student that spent the most if all orders were in the historic district. We now have this field of data with the total cost if all orders were placed in the historic district. So we can pretty much repeat what I did over on the right-hand side there already. We could do equals unique. Let's get a unique list of the students. There we go. And now we're going to do a sum ifs based on the historic cost field where the student matches the student name we've got here. Okay, now we could do a sort again, equals sort based on this array. We want to sort based on the second column. We want to sort in descending order. And the answer is going to be Steve Kerr. We could just copy that in, and that is pretty sure the right answer. Let's just double check. Steve Kerr. Okay, that gets us to the right answer. The final thing I'm going to do, just with that bonus question again, just to showcase a different way of doing this, is I'll just do it all in the array dimension. So let's see if we can set all of that logic up that I just did explicitly here, but we'll do it all within a nice let function. So here we go. I'm going to give myself a few extra rows of the formula bar here because I know I'm going to need it. So we'll do let. And the first variable we're going to set up, we will just call name unique. I've never been particularly good at naming things, but there we go, name unique. And that will be unique. I won't even go over to the table. So it's going to be our table that we called food data. It's going to be unique, a unique list of the student names. And that's it. That is literally the start of our first part of the formula. As I go through this with let, what I'll do is I'll just return the variables as I create them. So that would give me, I'll tell you what, because I'm doing that, let's do it over here on the side so you can see what happens. So that's going to give me the list of unique names. That's the first part of the let statement, which is exactly what I did explicitly over here. The second thing I did was I did a sum ifs, essentially a sum of all of the order costs for the historic field based on that list. So let's do that in our let statement. We're going to do a order sum, and it's going to be a sum ifs. What's the sum range? It's back to our FD table, and we want to pick up the total cost of the order as if it was from the historic district. And the criteria is going to be back in the FD table again. And it's going to be where the student name is equal to the unique list that we've just created, NM unique. Okay, let's just show what that looks like. Order sum. And now I've got a list of the sums of the orders by name. So I could do something quite nice here if we go back in. If we just wanted to look at this the same way we saw it explicitly, why don't we just do an H stack of the unique names, and that helps if I actually start the formula. There we go. Let's do an H stack of the unique names and the order sums. And there we go. That's, if we have a quick look at what that's getting us to, it's almost exactly what we've got here. Well, in fact, it is exactly what we've got there. Okay, but we don't want to do that quite yet. There's a few other things we want to do. So we could have this as a stopping point. So we'll call this stack. And then we could go to another row. And this time we'll do a sort. What are we sorting? We're going to do a sort of the stack that we just created. We're going to sort based on the second column. We're going to sort in descending order. And then if we return sort, helps if I put a comma there, we have our list sorted. So we can see the right answer at the top there. And we could then go even further and we could say, should we stick to best practice? Yeah, let's do it. So we'll create another variable called output, and the output will be the index of sort row 1, column 1. And we will return output. And that gives us the answer. Let's copy this whole formula in here. Steve Kerr. Now, I don't know about you, but under pressure, I would still find that quite hard to just keep kind of visually in my head as I go through. But I think it's a great target to have. If you are comfortable just explicitly creating data like this and then following these step-by-step kind of approaches, that works really well. If you can do it all in one cell, kudos to you. And I hope that walkthrough helps. What I'm going to add, actually, I'm going to showcase something. I'm going to pause the video and I'll come back. I'm just going to showcase something using this awesome new tool that has been created by Eric Owen called OA Robot. I'm going to run through a solution to this as quick as I can using OA Robot, and I think it will kind of blow your mind. All right, that took a little bit longer than I thought, so the lighting's probably completely changed. But anyway, I'm going to give you a really quick showcase of some of the things I'm working on with Eric Owen and his tool OA Robot. Now, the health warning here, this is a bit of a tease because not all of what I'm showing is available. It may be that some of what we're doing will be put together as part of what we're going to call a humble package, which would be quite funny, I think, in my head. It might be that these become part of a premium product with OA, but I am in a test guinea pig phase using things that are potentially going to have bugs in them or whatever, but I'm happy to do that. So just see this as a little bit of a showcase of some things that a tool that I think OA is so unique in this respect can do for micro automations. I'm not going to try and explain everything that is going on. I will talk a little bit about what I'm doing step by step where I think it's right to. Some of the commands I'm working on are actually just what you would do in the first few minutes of a battle. So one of the first things I would call up is a command with OA Robot that's going to back up all of the sheets. So one of the things you might want to do when you start is have a raw copy of any of the data that you've got. So I'm going to have back up all sheets. This is me calling up the OA Robot sort of user interface. That is going to run, and what you'll see in the bottom is just a copy of the worksheets popping up, which just means if I break anything in my live copy, I've got the backups there. The next thing I'm going to do is I'm going to call up a command that is going to name any of the ranges. So as I start typing in, a little bit like IntelliSense in Excel, it's finding these commands in my packs. Name used ranges on all sheets. Hit enter. You won't see what's happened, but essentially that's now named the key ranges in my food prices and food data tabs, and it's ignored the ones in anything with backup on the backup tab so that I don't have duplicates. The third one I'm going to call up, which I absolutely love and I will be using a lot, is one called split case levels. Hit enter. And what you're going to see happen is it's going to take the case tab and it's going to split that out into the bonus section, and then each of the individual levels, and one with all of the levels but none of the example lines, which is very, very useful. Now, I'm not going to go through all of these, and to be perfectly honest with you, because of the way some of these questions are in their complexity, you might be quicker just doing it the kind of normal function way. But I think this will sow the seed of how this might be useful. Let's take bonus question 2. Which food has the most quantity ordered across all 1,000 orders? Now, I started from a new worksheet, but because I went through that name command, I know that I can now start typing in the name of the tab with the data on it, and I've got 2 named ranges set up here. So I want to call up the food data table of data, and there we go. From here, I think to answer this question, all I need is the food and the quantity. So I'm going to highlight those 2 fields with my active cells, call up OA robot, and I'm going to start typing keep columns of arrays, hit enter. It's going to leave me with just those 2 fields from that named range that I want to answer this question. I've also noticed that I've got titles in my named range, so that first row I really want to get rid of so that it's not part of the analysis. So we'll do I think the shortcut is drop or remove. Maybe it is remove first n rows of array. It's going to ask me how many rows I want to remove. I want to remove the top row. So we're nearly there. What might I want to do here? I might want to group. So we've got all of those 1,000 orders at the moment. Group by sum. We're basing that just on the first column, so it's going to group this up a bit like you were doing a group by. And we can sort from here. So I've got all of these commands set up. We will do a sort by descending, sort array descending. And that gives me the answer at the top, which is going to be, once it's done its thinking, this is the only thing that I'm kind of working with at the moment, is sometimes it takes a few seconds, ramen noodles. Now, for that specific question, could you have done that quicker? Potentially. But if you've got more complex steps that you have to work through, this is a really nice way to kind of pick apart a data set very quickly. I'll see if there's, what else could we do here? How much was ordered across all? Okay, so this is kind of similar, but I'll show you another really nice feature of OA. Given a food, how much of it was ordered across all 1,000 orders? We've got a different food for each row here. So we need something that's going to essentially kind of look up against these values. Let's call up the food data table of data. Again, I only really want these 2 fields, so I'm going to keep food and quantity and remove everything else. So we'll do keep columns of arrays. It's just going to keep the active cell arrays that I've got, columns that I've got in the array. Okay, that's great. We don't need this top row, so we're going to again just remove the top row. Remove first n rows. We just want to remove the first row. From here, we can do our group by again. So call up robot, and we're going to start typing in group. Group by sum. How many columns are we going to group based on? It's just the first column there. All right, and then from here, what do we got? We've got each of the food products and the sum of the quantities, but I basically want this to be kind of dependent on what's in each individual row. So if I copy what I've got in cell G for this row, go over to my filtered array here. If I just start typing in filter, I want paste filter array by copied cell. If I hit enter on that, it's going to filter down my already filtered array, but it's going to be linking back to whatever is in column G for this particular row. Okay, so that's giving me the filter on spaghetti. I just want to keep the number column. I don't need the title spaghetti, so we'll do keep, again, keep column of arrays based on the active cell. There we go. And then if I copy this up to the example case, you can see it changes. Why? Because it's linking to this cell. From here, I can use a couple of other commands as well. So I can do, if we type in down, autofill down, it's going to copy that formula all the way down. From here, if I type in left, we've got save game answer to left. That's going to put it in the green cells for me. So some really cool little tricks that I'm showing with OA. Some of them aren't available to everybody for some of these questions because they're relatively simple in the wider context of these battle cases. You'd probably be quicker just doing it manually. But I hope that's a nice tease for what might be possible with OA Robot.